Stephanie Wehner is an IT specialist and a quantum physicist. On her way to work, she carries something that has the potential to change the world. In her bag is a small tool she developed together with her team at the Technical University of Delft. This tool will advance something she cares very much about. To me, communication is key. It's so fascinating in all its forms technologically. Not just A messaging B, but also communication among several computers in a network. That's where an unassuming little box comes into play. It could be the key to unlocking a possible quantum internet. An ultra-fast and extremely secure computer network, new communication technology that Stephanie Wehner is at the forefront of developing. To me, the most fascinating aspect is that we send a new kind of information, quantum information, and that will enable us to do things that are impossible on the regular internet. On the regular internet, we watch films, like this one, exchange data and transfer things into a digital world, which we used to do laboriously by hand, a transformation that has advantages and disadvantages. In fractions of a second, our messages travel the entire planet. Often these are intimate messages, meant for only one specific recipient, but potentially many copies of that message remain trapped somewhere on the internet. A quantum internet could solve such problems. One example is that a recipient could prove that they actually deleted information. Let's say someone sent me their medical information and they want to make sure that I deleted it after use. With quantum information, that is possible. Turning quanta into reliable carriers of information is the difficult and complex path Stephanie Wehner and her team are facing. At Europe's Quantum Internet Alliance, she leads researchers in making the phenomenon of quantum entanglement usable. Quanta are correlated or entangled in such a way that knowing the state of one automatically gives you all the information on the other. This entanglement is indivisible. When I have a particle and you have another, and the two are entangled, this entanglement forms a kind of private connection, and nothing else in the universe can be part of that. So outside influences are properly excluded. And that leads to secure communication, using this secret connection that the entanglement provides. That may sound hypothetical, but only a few kilometres from the Technical University of Delft, it's already happening in the real world. In the port of Rotterdam, quantum communication is being used to coordinate shipping traffic, making eavesdropping impossible. As of now, this only works across short distances. On the regular internet, the binary code made up of ones and zeros can be copied time and time again, and thus be passed along. The bits on the quantum internet can't be copied, which makes it hard to span large distances. That's why Stephanie Wehner and her team at the Quantum Alliance are developing technologies that will allow quantum communication over greater distances. But those ephemeral qubits don't like to stick around. Right now, it's really tricky to save these qubits for any amount of time longer than a few seconds. But Stephanie Wehner and her team already managed to overcome a different challenge for a future quantum internet with this revolutionary gadget that fits into a purse. They developed an operating system called QNode OS, which makes it possible to develop and run applications on the quantum internet without the need for special training in quantum physics. The contents of that small grey box have the potential to turn the quantum computers of researchers into a quantum internet, an outstanding milestone in communication technology. The next step towards a working quantum internet is to make these systems usable outside our laboratories, in the real world. A groundbreaking next step that Stephanie Wehner is in the process of setting up.